Hello Lenny, hello Via. How long would this session be? Probably about an hour. I might have to leave a bit before that, but hopefully about an hour. Lenny, you say vectors A-levels. Anything, I mean that's a really big topic, vectors. So what could you say about vectors? What are vectors for? They are for, well, a vector is, it has a size and it has a direction. Hello Claire. So, or a magnitude. Usually we call it the magnitude when we're talking about vectors. So typically they're in A-levels they're used in mechanics, in the mechanics section, in terms of particles, the movement of particles. So the particle has a direction, and it also has the magnitude of the vector indicates its acceleration usually, or yeah, usually it's acceleration or its speed, depending on, well, I guess if it is accelerating, it will have both a speed and a acceleration. Although if something's accelerating, we don't really talk about its speed because that's constantly changing. So if something is accelerating, it will have an acceleration vector. If it's going at a constant speed, it will just have, you know, a vector of constant magnitude, indicating its direction and the speed that it's going. So usually we talk about, you know, what's going to happen to that particle over time. So is it, you know, is it a ball being thrown? In which case, what are the forces acting on that ball? In A-levels, we really only talk about gravity. We don't talk about like air resistance. So it's just gravity pretty much for in terms of particles moving through the air. Or you might be given, you might be told you have a particle moving in a certain direction. Oops, that's a terrible line. You might have a particle moving in a certain direction, and you're told there's also a force acting on that particle. So you'll be given a force vector as well, and you need to figure out, well, how does that force affect that particle? The vectors are usually given, there's two components, or sorry, three components. Trying to just think of an example. Via says, I'm going into year 12 in September, so do you think it would be beneficial if I start learning A-level content early? Yes, I think it would be beneficial to start learning A-level content now, definitely. For sure that will be beneficial. So let me just pull up a question actually. Let me pull up an example. from last year's exams. Let's look at, let's see, this one. This was the mechanics section from last year's exams for A-levels. This is A2. And let's see, it was the first one. Here we go. Yeah, so they have two components. Two components to these vectors. Hi Ryan. Hey, I just wanted to ask, will there be GCSE exams in October, November 2020? And is 3 months enough to do revision as well as past papers? I'm not sure about IGCSEs. I'm not sure what's happening with those. And 3 months? 3 months is a good amount of time, depending on what else you have going on. Like if you have other subjects to revise for. Depends really. How much time do you think you can commit to mathematics every day? I mean, if you do like an hour every day for 3 months, then I think that's plenty of time. Depending on what point you're at now. And is 3 months enough for past papers? Yeah, I think so. I would suggest, I don't know where you're at or what your situation is, but do a set of past papers now and just see what, and then grade them strictly. So be really harsh on yourself with the grades. Like if you don't have the exact answer that the mark scheme is looking for, mark it wrong, see what mark you get, and then revise the topics that you're not strong on, and then do a set of past papers in 2 months maybe. I finished all the subjects, I'm just going to have to start past papers. Yeah, okay, yeah, it's a good strategy, I think. So yeah, so in terms of vectors, in this example we have a particle p that's moving with a constant acceleration 2I take 3j. So the I and the j, they're kind of indicating separate axes of direction. So it's moving on a two-dimensional plane. We can add a third. I don't think we do this in A-levels, but you can add a third dimension, and then that's simulating three-dimensional, the world we live in. But for A-levels, we just focus on on particles moving in 2 dimensions, I and j. I being the horizontal axis and j being the vertical axis. So that's what you're seeing there in terms of that vector 2I take 3j. It's a particle moving in 2 dimensions. For every 2 units horizontally, it's moving down 3 units. Well, we're talking about meters here. So 2 meters across, 3 meters down, that's your vector. Hi Savage. Hello Nishat. Welcome. So that's if you're given an acceleration vector, and then this question is saying at time t equals 0 the particle is at point A and is moving with velocity negative I plus 4j. So that is a velocity vector. It's not accelerating at all. It's just, it has a constant velocity. So that is kind of an introduction to the ideas of vectors. I'm not sure how far you want me to go with this, Lenny, if you had a specific question in mind. If you want to see the full solution to this question, check out my walkthrough of this paper. I went through this question in the video, so I'm not going to do it again here. Feel free to watch that video at any time. But, well, I mean, the gist of this question is saying P is moving in the direction, that's a direction vector, So in this question, you're given the three types of vectors that we usually focus on: direction, velocity, and acceleration. Derivatives in, I don't think there's derivatives in IGCSE, no. I think calculus in terms of GCSEs is not in any of those curriculums. Nishat, yes, this is A-level. This is A-level A2. Hey, Sablashan. Okay, so that was just kind of a brief sort of like introduction of the ideas of vectors. What else? Well, I guess the theorem that really is often really useful with vectors, well, there's actually a few. I mean, to get the magnitude of a vector, you're always going to use Pythagoras, right? Because this vector here, 2i take 3j, that represents a right angle triangle. If you think about these two, this I, the coefficient of I and the coefficient of j, as the legs of the right angle triangle. So if I'm just talking about this vector, 2i take 3j, this means that we're going across 2 for every 3 units down. So that creates a right angle triangle. And to find the magnitude of vectors, you always want to use Pythagoras. So that's a really useful theorem when you're talking about vectors. And the other thing to know is all of the Suvat equations. So they're actually in your mark scheme. Sorry, not mark scheme, your formula booklet. So let me pull these up. Where are they? These ones here. So these equations are really useful in terms of vectors. And the other thing to know is that you can bring calculus in. So the derivative of velocity is acceleration, right? The rate of change in speed, the rate at which your speed is changing is acceleration. That's the derivative of the velocity. And the integral of velocity is direction or displacement. So it's how would you say that? It's how far you've traveled in that amount of time, right? It's kind of like the area under the graph. So the integral of velocity is displacement or distance traveled. Which do you think is better, IB or A-levels? I actually don't have much experience teaching IB or even much experience of the curriculum, although everything I've heard says, or everything I'm told, is that IB is a little bit harder than your general curriculums. I think IB is designed to be quite challenging, but I could be wrong. Sablashan has a question, an algebraic question. Okay, so let's do that one. Famida, welcome. Via, will I be able to understand if I haven't started learning A-level yet? So just I would suggest trying to kind of familiarize yourself with the main topics. So start with like really introductory calculus. So what are the basic ideas of calculus? So maybe start there. Molly, welcome. I love using your GCSE papers revision videos. I'm year 10 and they're useful because we have been told to revise things we have already done. Great, thank you. Thank you, Famita. Sabrinda, welcome. Okay, so let's do, was it a simultaneous equations question? Might just rub these notes off. We had y equals 6x squared plus 3x take 7 and y equals 2x plus 8. And solve this graphically, so with a graph. Right. Do I do these every day? No, not every day. I did one yesterday, and not last week, the week before I did 3. So I'm trying to do them fairly often, but I can't guarantee that they'll be every day at this point. But there will be, or they should be more regular, especially over the summer. Depending, I mean, it depends really. If no one's tuning in, then I'm not obviously going to do it. And over summer, well, I'm not sure if people want to be tuning into a maths live stream over summer, but we'll see how it goes. Okay. All right. So let's try this graphically. I guess I have to draw the graphs myself. Oops. Although I think in GCSEs they usually give you part of the graph, or they would give you the quadratic, but let's see. So well, this is a positive quadratic, so I know it's going to be like this, like a smiley face, up that way somehow. And so what I want to determine is the vertex, so the minimum of the quadratic, and the x coordinates. So what I'm going to do is complete the square on this, I think. Or I could try to factorize. 7. Maybe factorizing is easier, actually. No. That's not going to work. Okay, let's do completing the square. And so I divided through by 6, and then I want to take half of this coefficient, and that is all squared, so x plus a quarter all squared. Taking half of a half is a quarter, so this is a method to complete the square. And then you subtract a quarter squared from the constant on the end. So 7 on 6 take 1/16. This is already looking not very fun, but we'll give it a go. So now I want to combine these fractions. 7 on 6 take 1/16. That's kind of horrible. A common factor between the lowest common multiple of 6 and 16, I believe, is just 96, I think. Unless there's a lower one. I don't think there's a lower one. 2. Oh, 30. 48. Sorry, 48 is lower. So we can do 48. Okay. So 16 times 3 is 48. 6 times 8 is 48. So we could then... So we've multiplied this one by 8. 56 take 3 is 53 on 48. I believe that's correct. Alright, so this gives me the vertex of the quadratic, which is, so the vertex, this is called, what's it called? Vertex form, I believe, after you do completing the square, and it is the negative of the number inside the brackets, and just the constant on the end as it is, so we don't have to swap that one around. Alright. So I have the minimum of this quadratic of -1/4, -53 on 48, which is just more than 1, I guess. So if we did a scale, actually I'm not sure what this scale should be yet, because I haven't found the x coordinates, but let's see how we go. Alright, -1/4, that's about here, and just more than -1 on the y-axis. Alright, so that's my quadratic. Oh yes, the 6. Yeah, what have I done here? Sorry. Yeah, I meant to factorize the 6 out. Not divide through by 6. Apologies. I'm messing up my algebra there. So you can't just divide through by 6, you have to factorize it. Okay. Yes. So, what have I done? 6. Yeah, I've messed all of this up. I don't know what I was doing. I must have had a mental blank. So you factorize the 6 out, of course. And then you multiply it through back through. Apologies for that. I don't know what I was doing there. Alright, so am I on the right track now? Please let me know. Oh, I was... Oh, I guess I still... Okay, just let me start again. So you factorize the 6 out, you have 7 on 6, and then you have x plus a quarter all squared take 7 on 6. Yeah, and then you can multiply it through by 6 again. So you have 6x plus a quarter all squared take 7. Okay. Oh yes, but then the turning point would still be the same because you still have that. So actually, what I was doing at the end was correct. So the vertex still is as I said it was. Okay, I rubbed all of that out for no reason. Okay, all right. Okay, so we have the vertex of negative a quarter, negative 53, and 48. Now we need the x-intercepts. Now we need the x-intercepts. So we could use which one? Which one? This one. So let's say that 6x plus a quarter all squared take 7. Let's simplify this on the end. So this would be oh my gosh, I'm making a real mess of this, aren't I? An absolute mess. An absolute mess. Why do you have to give me these horrible questions with all of these numbers? It's so easy to make numerical mistakes and things like this on questions like this. Like, these are the kind of questions that I really don't like in mathematics. It's just messy and annoying, and I always make silly mistakes. Especially with fractions. Okay, so yes, this is right. This is right. And then we multiply by 6 again. Oh. Yes, so yes. So this was 53 on 48. And then we multiply by 6. This is 53 on 8. Okay. So this is negative 53 on 8. All right. Here we go. So now we want to let this equal 0. Oh wow, what's everybody saying? So many messages today. Okay, I can't read all of that. Alright, so hopefully I'm on the right track now. Somebody let me know now if I have anything wrong. I think I've got this right now. Okay, so now we have this set to 0, then we can find the x coordinates. Alright, so then add that 53 and 8 to the other side. Divide by 6. So 53 on, well, we have that 48 again. And then take the square root. Oh my lord. What is this question? This is disgusting. Why did you give me this? Beef, beef, beef. Are we talking about beef? Via says he's a vegetarian. Please not talking about beef. Because we have vegetarians in the chat. So more broccoli, please. Yeah, I'm not sure you can really solve this graphically. Like, I don't see how I'm going to get a graphical answer to this. Well, this was Sabalashan's question, I believe. Solve these equations graphically. Yeah, I'm not sure. I can assure you this type of question would not come up in a GCSE exam unless they give you the actual graph. They would give you the graph and they'd ask you to identify the point of the points where the line and the quadratic meet. So they would not just give you these equations and ask you to graph them. They would actually give you the graph and to find the solution that way. So anyways, this would be something like, I don't even know what this is. Root 53 on 48, take a quarter. I don't know, let's get a number for that. Oh yes, so Luke, I'll go back to your question. 53 on 48, take a quarter. 0.8. Oh, it's plus or minus, by the way. Plus or minus. So like, it would be like this. And then you have the line 2x plus 8, which would be, I don't know, up here somewhere. Yeah, I don't think this, I have a feeling this is made up, or else there's meant to be a graph with this question, but I would say this is not a GCSE question that you would get given to you. All right. Yes, you're right, Via. It was plus minus the square root. Luke, could you actually, let me see if I can find it again. Yeah, I can't. Do you mind posting the question again? I can't seem to find it. There's too many messages. Okay, so if you have other questions, feel free to post them. Okay, so just going back to that, if you're wondering why I said, the question was to solve this graphically. Solve graphically. And we ended up with a vertex of -1/4, -53 on 8. And then x-intercepts of root 53 on 48 take 1/4. Okay? So already, this is like a really messy problem. Okay? This is some irrational number. So they're irrational x coordinates. And then you need to draw this somehow. So how are you actually going to draw that if you have irrational x coordinates? It's going to be an approximation. So rather, you would probably solve this algebraically. I would say the question would be saying solve this algebraically. And that is also horrible because the x solutions for this quadratic are irrational numbers. They are these square roots, negative and plus root 53 and 48 take 1/4. So you have to substitute that into this. Okay, so it's just messy and horrible, and I don't know. Okay, so this is the method that you would use. But just to finish it off, how am I going to get these? How am I actually going to draw this and get the weather intercept? I don't know. I can assure you that you don't need to, I don't want to worry about it, so you don't need to worry about it. That's basically it. And yeah. Oh, sorry, I missed something. How do I use the derivative to determine whether a function is concave or convex? Okay, so so if you had a cubic, for example, yeah, so if you have a cubic, and then you might want the derivative, so that the change in y with respect to x, use the power rule on each one. So you've got 3x squared plus 6x plus 4. And then you can look at the second derivative, and that tells you the rate or the change in the derivative with respect to the change in the derivative of x. So this is 6x plus 6. Or Actually, I don't know. So concave and convex, how are we using the derivative to show that? Well, it depends really. It depends on what the context of the question is. So if you're just looking at a section of the graph, yes, it's like this, right? So it's asked to talk about the section of the cubic, whether that part of the graph is concave or convex, right? That's the idea of the question. So let me draw the graph a bit clearer. So a cubic will look like this. It goes up and then down and then up again, and keeps going up that way and keeps going down this way. And you have a point, you have a maximum, a local maximum, a local minimum, and then a point where I forget what that point is called again. Does somebody remember what that point is called? The point of inflection. The point of inflection, where it goes from where the derivative goes from becoming more negative to more positive. So in this section, how can we draw this? Maybe with a line. In this section here, the derivative, the rate of change, or the change in y with respect to x, is becoming more positive, right? If you look at this line here, if you look at this line, what would you say the slope of that line will be? Well, it has a negative gradient. And this one has a positive gradient. So you are going, so in this section that I've highlighted in red, the derivative is going, the tangent of the slope is going from negative to positive, so it's becoming more positive. So it's becoming, the derivative is becoming more positive, so the change in the derivative will be positive in those points. So you can pick, you can pick an x-coordinate in this section, and the second derivative will be positive. However, in this part, let's use a different color. In this part, in purple, of this cubic, the change in the derivative is it's becoming more negative. So if you draw a tangent to the slope here, and then a tangent to the slope here, this tangent is has a positive gradient. This tangent has a negative gradient. So you can see that the tangent, the slope of the tangent is becoming more negative. So that is this second derivative. Okay, so if you put an x coordinate, use an x coordinate in here for that cubic, then you would get a negative. A negative value. All right, so that is how you use the derivative and the second derivative to find if the graph is concave or convex. So which is which? I always forget. This is convex, right? Because it's upside down, and this is concave. Anyways, I think that's on the right track of the question. I hope that helped. Tomorrow is Minnie's birthday. Everyone wish Minnie a happy birthday. Happy birthday, Minnie, for tomorrow. Luke says, okay, thank you. Alright, so hopefully that's a general idea. Was that the type of question that you were looking at, like cubics and graphs like that? Okay. Any other questions? Does anybody have any other questions or topics that they want to talk about? Sablashan, what was your question again? Do you mind if you post it again? I don't have a way to kind of keep track of them. Unfortunately, it just kind of gets lost as the chat goes down. So if you could post it again, that would be appreciated. How does 1 equal 2? Well, in an alternate universe, perhaps 1 does equal 2. The interesting thing about numbers is that we have to accept the facts. The fact that 1 plus 1 equals 2. In the 20th century, they tried to redefine mathematics. They tried to ground it on set theory. So if you go to university, you study, you get into like abstract algebra and analysis and all this horrible mathematics. And the point of it is that therefore it's not grounded on the fact that we have to accept that 1 plus 1 equals 2. However, if you actually just want to do like regular mathematics, you just have to accept that 1 plus 1 equals 2. And 2 plus 2 equals 4. And 3 plus 3 equals 6, and so on. Because if you take two objects, you can see that this object and this object make two objects. That's just the idea of 1 plus 1 equals 2, right? We can just see and experience that that is the truth. And there's no, there's nothing underneath that. You just have to say that that is what it is. Is it possible to find a quadratic simultaneous equation solution using matrices? Yes, you could. I'm not going to go into that, partly because I don't remember how to do it, but also because it's not in GCSE or A-level mathematics. Have a good one, Famita. The factorization question. 6ab squared take ab take 6ab. 6ab squared take ab take b squared. I don't see anything. Oh, actually. What have I done? Oh. I just see a common factor of b. Although there might be. There might be. Oh yeah, it's a quadratic. Oh yeah, you could just do it this way. So you could just do it the fundamental way. Is that the way to say it? Oops. What was I going to say? What am I doing? A. Ah. A, B. No? Oh, there's no. Oh, 6a squared. That's why I was getting confused. Sorry. 6a squared take ab take b squared. Oh. Oh. Yes. Right. So this is kind of. Yeah, so it's like a quadratic, except instead of the, I mean, usually you would write a quadratic like with the number on the end, right? makes a bit more sense if you write it that way. That's what you might be used to seeing it as. Because then you look at the factors of 6 that make -1. So, but if you write it this way, obviously it still is fine. But then you see that you have a b and a -b and a 2a and an a, 3a, and we need the -3a and the +2, and you get negative b squared take ab plus 6a squared. So b plus 2a, negative b take 3a. Wait. Sorry, they're both positives. And this is a negative, this is a positive. Okay. Alright, actually, so what did I write initially? I wrote 6ab squared take ab take b squared. Yeah, I don't think there's anything you can do with that other than to factorize the b out. Okay. Alright. Any other questions? The root of -1. So well, it depends where you're studying. In Australia, we learn about imaginary numbers in year 11. In the UK, I think you learn about imaginary numbers in A-level further mathematics. Or at university. I'm not sure where the imaginary numbers come in the UK. But in Australia, we start learning about them in year 11. And imaginary numbers, they're useful to get to an answer, right? So if you have a quadratic like x squared equals -1, we used to think it doesn't have an answer. Like, there's no number you can square to get a negative number. However, by saying that this does have an answer, by saying that x equals I, that allows us to work our way towards other solutions. Like, you might end up with a real answer, even though in the working out, in getting to that real answer, you actually use I. So we have given this, essentially we gave this equation a solution. We said the solution is I. A complex number is, well, every number is a complex number actually. So 5, you could say, is 5 plus 0i. So every number has a real part to it and a complex part to it. So the real part and the imaginary part. And this can actually be visualized on a set of axes. So the imaginary plane is something that was added to the plane of real numbers to to allow us to solve equations that we previously could not solve. Square root the whole thing. Square root the whole thing? Okay, so square the whole thing, but then you would get x to the power 4 equals 1. X to the power 4 equals 1. And that's actually an example of an equation that you can solve using imaginary numbers. This would have 4 solutions. This would have, the solutions to this would be x equals 1, negative 1, actually what would they be? Is it? No, that's not right. Is it plus or minus I? Or is it just I? I'm forgetting. With I, does it have a plus or minus? I haven't done this stuff for a while. Or is it just I? Philek, welcome. What is the best concept about limits? Actually, I was listening to an interesting podcast the other day. About Zeno's paradox. Plus or minus I, okay. Thank you for reminding me. About Zeno's paradox, which kind of gets at the heart of this idea of the limit. So Zeno's paradox, I don't know if any of you have heard of this before, but Zeno was a Greek philosopher, and he will come up with these paradoxes to challenge our ways of thinking about the world. So he said that nothing moves, right? This is his hypothesis. Nothing actually moves because, and his example is, if you fire an arrow at a target, if you take any position of that arrow, in that instance, the arrow is not moving. Okay, right? If you want to take a particular point in the flight of that arrow towards its target, it's not moving. However, the arrow still hits the target, right? So his idea is or the question, I believe, is how does anything actually go anywhere if at any particular point the object is not actually moving? And this gets the idea of limits, because this is the question that calculus essentially answers. Calculus says, well, we can look at the speed of the arrow over a tiny fraction of a second, right? And then it's moving. And we get closer and closer to 0, and we assume the limit as the distance that the arrow has traveled approaches 0. And that's the idea of the limit. However, philosophers still have problems with this idea, because if you actually think about it, like how does anything get anywhere? It's the same as that the paradox with the runner. Like, how does the runner catch up to the turtle, right? If it has to, or how do we cross a room, right? If we have to cross half of the room, and then half of that distance, and then half of that distance, we never actually get to the other side of the room. But we do get to the other side of the room. It's kind of like our concept of, or our understanding of what's the idea of the limit, or the idea of infinite what's the word? Infinite fractional distances, I guess. And like, how does that become, how does that equate to us actually crossing the room? Yeah, it's the same. Yeah. So if there is infinite points, then why do we? Yeah. So that's one of Euclid's postulates as well, right? That any line is a set of infinite points. So actually, let me see if I can pull something up. So let's watch. Let's see. Actually, maybe that's another time. I think I have to go in a minute anyways. I was going to watch a video on Zeno's paradox, but maybe another time. Okay. Actually, I was going to play chess. Like, I've been meaning to play chess in, like, if nobody was tuning in or had any questions, I was going to play some. Actually, I could play a game now. But I haven't, like, I've just been watching chess. I haven't actually been playing. So I don't know how it will go. All right. Yeah, okay. So let me know if you want me to play a game of chess. A really bad game of chess. Just to finish off. You want to see me at least once play chess. Okay. So you can see I created a channel, Maths Explained. If you want to go, this site is called lichess.org. If you want to come on here and challenge me, feel free. It's maths_explained. Alright. Alright, so I don't know what time control to use though. So Ryan says, you play chess. No, I don't play chess, but I've been watching chess. So recently chess has been really popular on Twitch. Like, everybody's playing chess. All of my favorite streamers are playing chess. So I've kind of been wanting to play, but I used to play when I was younger. So I know some ideas, but I haven't played for a long time. Philic, no, I don't have a playlist on calculus yet. I'm meaning to put one together, but it's such a big topic that it's taking me a while to kind of make the videos. Like, I want them to be quite good, like a good introduction to calculus. So I'm meaning to make those, but I don't have one yet. All right. What time control? I see people usually play 10 minutes. E. Yeah, E is a constant. It was actually discovered by, I forget who. It was discovered by somebody studying compound interest, so the idea of compound interest, and they discovered this constant E. As you keep compounding something over smaller and smaller periods, you get this exponential constant E, and it's 2.7 and so on. All right, so 10 minutes you think, because I'm a beginner, okay? All right, so let's go, let's play. All right, so I've got to go first, I think, because I'm white. All right, so I remember the important idea, or the important point that I remember is that you need to control the middle of the board. So these 4 squares in the middle, if you can control them, it's like you control the entire board and then you win. That's all that I remember. Okay. So right now, he's attacking my piece and I need to defend this, right? Because he can take it. So I'll defend it with the knight. Or I could have defended it with the queen. That's cool, look at this. I can make arrows. Whoop. 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 Look at this. Look at my tactics. So I'm going to go here and then here and then here and then eventually checkmate. Alright. This site is called Lichess.org. Alright, so he can go here and then here. So I need to defend this pawn again. I might do it with the bishop. He's probably wondering why I'm going so slow. I'll try not to use all my time because I know that when I'm talking I'll probably be really slow. Alright. Okay, let's defend this pawn because he's attacking it, so I'll defend it. I've blocked my bishop. Uh-oh. I've done something wrong already. Am I about to get checkmated? Oh no. Whoop. I could attack this knight. But he's attacking this pawn twice. Boop. Boop. So I need to defend this pawn. Let's defend like this. Via says, sir, is the drop-in session daily? Not daily at the moment. There are some days where I can't do it. But hopefully there'll be one tomorrow. At least I can say hopefully one tomorrow as well. Is there a question that I missed? Yes, Luke says E is the limit of n to infinity, essentially infinite compound interest in an interval. Awesome. Okay. Alright. So this Are you ready for this move? Are you ready for this move? This is called castling. Are you ready? See what happens? Actually, no, I'm not going to castle. I'm going to play this. E5. Hey, somebody sent me a message. Oh no, somebody challenged me. Alright, I won't have time to play another game. I have to go after this, unfortunately. Chess, the GCSE subject. So all I'm doing here is trying to control the middle of the board. That's all I remember, right? If you can control the center of the board, then you win. I used to play when I was younger. Ryan challenged you. Unfortunately, I really do have to. I don't even know if I'll be able to finish this game, to be honest. I probably shouldn't have played a 10-minute game. Tyroya 1? Did you have a question that I missed? Okay, so what's this queen doing? I don't know what that queen's doing. I am just going to bring my bishop out. Okay. So I have to move this bishop because the pawn is going to take it. So far so good. I haven't lost any pieces. Did you see that? He castled. That's what castling is. Apologies if I missed any questions. If you still want to post maths questions, then feel free, and I'll try to answer them. What now? What now? I don't know what to do. Uh-oh. Um, why is the median more accurate than the mean? Depends on the context. So, um, the median is not affected by outliers as much, because the median is the middle value, the central value. It's not affected by huge outliers. A common example is house prices. So you can have houses that are worth millions and millions, and they're outliers, but the median value is the more common value taken for house prices. I don't know how to play chess, but I haven't lost yet, so that's a good sign. This is what these so really good players in chess, they're called grandmasters, and when you watch them play, they're like, yeah, then I go here and then here and then here, and I take this and this and this, and then I checkmate. It's really fun to watch, but I don't really know what's happening. And then I go here and here and here, and then I take this and this and this, and then I take this, and I win. Minesweeper. The thing I don't like about Minesweeper is that you have to guess. Like you have to guess some of it. That always annoyed me. And the thing on principle that makes chess fun is that it's completely logical. So like there should be a reason that you're doing what you're doing. Although for me there is no reason for me doing anything at this point. The reason I did this is then I can take the knight with the bishop. Because now it's not defended, right? The queen was defending this knight, but now it's not, so I can take it. There is guessing in Minesweeper. There is guessing. I think it's been proven that you have to guess in Minesweeper. There's no, you cannot work out all of it. At some point you have to guess. So now I took all the pieces. I don't know why. I'll probably lose. But I have an extra knight, so that's good. Okay, I have to go. I just have to finish this game and then I'll go. I'm just going to go here and then 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 I'll checkmate. Yes, I'm also winning on time. That's true. Yes, I'll try to do a stream tomorrow as well. Check. Look, check. But it's not mate, I don't think. Integral of sec half the square root of sec x. I actually don't know off the top of my head. I'd have to work it out. But the integral of sec squared is tan x. So I guess you could square it. Yeah, and then you would... no, I'm not sure. Oh no, is he going to get a queen? If he gets a pawn to the end of the board, it becomes a queen. But I can take that, right? Yes. I'm going to win on time. Should I give him more time? No, I've got to go, so. Okay. Okay, he ran out of time. Alright, good game. I have to go. Thank you so much for tuning in. Whoa, look at my rating. I just went up 196 points on my rating. Wow. Yeah, thanks for tuning in. As always, this was a lot of fun. Hopefully you can join me tomorrow. See you then. Bye for now.